Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a database design concepts, but with a new chapter, that is a chapter number 10, that is a file storage and the file structure. So let's start with the part number 3, that is the data storage and the querying. That is how to store the data and what is the data querying, or what is the data storage and the querying, that is the data storage and querying. So let's start with the previous class session, what we have covered in the last class, then moves to the next topic, that is moves to the today's topic, that is the part number 3, that is the part number 3 of this book, that is the database concepts or the data storing and the querying. So let's start with the previous class session, what we have covered in the last class. In the last class we have finished with chapter number 9, that is how to use the various application design development and how to make the development easier. So in the last class we have talked about the encryption techniques, that is how to encrypt the data. So encryption is nothing but changing the form of a meaningful form into a unmeaningful form that cannot be understood by the common person. That is a encryption means changing the data from one form to another form. So that is there are many various techniques that is available from the encryption, right? So simple a technique that does not provide adequate security because it is easy to break the data. So encryption means refers to process of transmitting the data that is in a form that is unreadable unless the reverse process of decryption is applied. So it is a process of transforming the data into a change into unreadable form unless it is retrieved by the decryption method. So until and unless we cannot apply the decryption method, there is no criteria to access the data, there is no criteria to make the data or form the data, or we can say the convert the data into the meaningful form. Encryption algorithms uses an encryption key to perform encryption and requires a decryption key. So whenever I want to apply encryption, so I want an encryption key, and for decryption, that is changing into the original form, then I want a decryption key. So there is an encryption key, there is a decryption key. So the oldest use of encryption word for transmitting the message is encrypting using a secret key that is known to the sender and the receiver. So for transmitting the data, for sending the data, for receiving the data, there are two keys that is used. One is the encryption key, one is the decryption key. Encryption key is used to encrypt data, and decryption key is used to decrypt the data. Then there are various encryption techniques that is used for the encryption. There are various algorithms. One of the important algorithm is the RSA algorithm. So we are not using the simple techniques for encryption because it is very easy to break the encryption. That is a simple technique. So it is very easy for the unauthorized user to break the code. So in case of the weak encryption techniques, consider the each character with the next character in the alphabet. So it is very easy to break the encryption, or break the, we can say, the new form into the original form. That is, if I send the data, if I read the data, or if I convert the data in a simple encryption technique. For example, one of the example that is given is changing the, or changing the character into the one character above. That is a one character above, that is the changing the character. So we have also studied about the what are the various properties that is used in the good encryption technique. So if I apply the good encryption technique, that is a technique that is used to encrypt and decrypt the data. So what are the various properties of good encryption technique? So it is relatively simple for authorized users to encrypt and decrypt the data. So it is relatively simple for the authorized users, that is how to retrieve or how to encrypt and how to decrypt the data. It depends not only on the secrecy of the algorithm, but rather on a parameter of the algorithm. So it not only depends on the secrecy, that is how to use the algorithm, but also the parameter of an algorithm, that is what are the encryption keys that is used to encrypt the data. So in a symmetric, there are two types of encryption keys that is available. There is a symmetric key encryption and there is a asymmetric key encryption. So there are two encryption techniques that is used. One is a symmetric key encryption, one is the asymmetric key encryption. And there is a standard that is used, that is the advanced encryption standard, and there is a DES, that is the data encryption standard, that is used in the encryption techniques. And there is a concept that is known as public key encryption, that is an alternative scheme that avoids some of the problem that is faced by the symmetric key encryption techniques. and it is based on the two keys. So there are two keys that is used in the public key encryption. There is a public key, there is a private key. Now, next is the encryption support in the databases. That is, what is encryption support that is available in the databases? Then encryption and the algorithm authentication. That is, what is the relationship between the encryption when we encrypt the data and the authentication when we authenticate the user. That is by providing the username and the password. A more challenging secure system involves a challenge response system. The database sends a challenge string to the user. The user encrypts the challenge string using a secret password that is used, and then makes the password, then uses the encryption key that is used, and then returns the result. Public key systems can also be used for the encryption that is used, and the smart code also provides a, we can say, the method solution to the problem that is given. And there are two concepts by which the encryption can be formed. One is a digital signature, one is a digital certificate. Digital signature means a signature that is formed on the, we can say, the signature that is formed by the using the digital signs, by using the digital role that is used to verify the authenticity of the data. Digital signature plays the important role of physical signature on the document. The private key is used to sign, that is to encrypt the data, and signed data can be made public. Anyone can verify the data, anyone can verify the signature by decrypting the data using the public key, but no one can generate the signed data without having the private key. So if there is a private key, there is a public key that is used. So we have to apply the data, we have to design the data that is available with the private and the public keys. Furthermore, digital signature also serves to ensure non-reputation. Yeah, that is, in case the person who creates the data later claims that she did not create it. So we can prove that a person have created the data, that is, unless her private key was leaked to others. Then next is the digital signature. That is a digital signature that is used, or digital certificate. That is certificate that is also made online. That is the digital certification. Authentication in general is a two-way process where each of the pair of the interacting entities authenticate itself to the other. Such pairwise encryption or authentication is needed even when the client contacts a website to prevent a malicious site from masquerading a legal website. So there's a digital certificate that is available, that is legal, and that is not, we can say that this is not authorized or this is not accessed by the unauthorized users. So for a user to ensure that she is interacting with an authenticate website, she must have the site public key. So authentication can be handled by using the digital certificates where the public key is used or are signed by the certification algorithm or agency. So there is an agency, that is a certification agency, that signs the public keys whose public key is well known. Then a digital certificate issued by a certification authority A consists of a public key, encrypted key that can be embedded by the public key and the private key. Then digital certificate is also used to authenticate the websites to the user to prevent the malicious sites from masquerading other websites. Then digital certificates can also be used for authenticating the user. So it is also used for authenticating the users, whether the user is authenticate user or not. The user must submit a digital certificate containing her public key to a site which verifies that the certificate has been signed by a trusted authority. That is, a certificate has been signed by the trusted security that verifies that it is verified by the authority of the sign. The user's public key can be changed or can be used in a challenge response time or system to ensure that the user processes the corresponding private key, thereby authenticating the user. Now this is a summary that we have discussed, that is, what is a summary, what is the crux of this chapter. Now next is part number 3, that is the data storage and querying. That is how to store the data and how to query the data. That is the data storage and the query. So although a database system provides a high level view of data, ultimately data have to be stored as a bit on one or more storage devices. So although a data will be stored, or although the data provides a high level view of data, that is how the data will be stored, that is there are different views of data. But ultimately, the data have to be stored as a bits on one or more storage devices. That is, the data can be stored in the form of the bits, that is either 0 on the 1 on the storage devices. A vast majority of databases today store data on the magnetic disk. So whatever the data So whatever the data that is available, so the databases can store the data on the magnetic disk, that is on the flash drive, and fetch the data into the memory for processing, copying the data into tape and other backup devices for the archival storage. That is how to archive the storage, how to fetch the data. The physical characteristics of storage devices plays a major role in the way data is or data are stored. In particular because of the data storage that is used. The data to access at random piece of data on the disk is much slower than the memory access. Disk access takes tens of millions of seconds or tens of millions of milliseconds, whereas memory access takes a tenth of the microsecond. Chapter number 10 begins with an overview of the physical storage medium, that is how to store the data in a physical medium, including the mechanisms to minimize the chance of data loss due to a device failure. So with the inclusion of the data storage, with the inclusion of the data loss that is due to the service failures. The chapter then describes how the records are mapped to the file, that is how the records are stored in the files, which in turn are mapped to the bits on the disk. So first of all, how to store the data and what are the various bits, how to record the data, how to map the data into the various bits. Now, many queries reference a small portion of the records in a file. So there are many queries that is available that reference a small portion of the records in a file. And queries are also used in the files. An index is a structure that helps locate desired records of a relation quickly. So if I want to search out any record in a quick manner, in an easy manner, that can be done by the index. So index is nothing but a structure that helps to locate desired records of a relation quickly without examining all the records. The index in this textbook, for example, is unlike the indices. It is meant for human use. Chapter 1 or 11 describes also the what are the various indices or how to maintain the index in the database system. Next is user queries have to be executed on the database contents. So we have to access, or we as a user can be able to access or can be able to execute the databases, execute the content on the databases which resides on the storage devices. It is usually convenient to break up the queries into smaller operations roughly corresponding to the relational algebra operation. So it is more convenient to break the query into multiple parts or break to multiple operations, smaller operations that is relational or that is related to the relational algebra operations. That is how to perform the relational algebra operations. Chapter number 12 describes how the queries are processed, how they are presented for implementing the individual operations, and then how to outline how the operations are executing in a synchrony to process a query. There are many alternatives of processing a query. That is, there are many alternatives that is used to process the query, which can have widely varying costs. So there are widely varying costs that is available. Query optimization refers to process of finding the lower or the lowest cost method of evaluating a given query. Chapter number 13 describes the process of the query optimization. That is how to get the query or what is the query optimization, how to maintain the queries. Right. Now, next chapter is chapter number 10, that is the storage and the file structure. That is what is the storage and what is the file structure, how to maintain the storage or how to maintain the file structure. So in the preceding chapters, we have emphasis on the high level model of a database. That is at the conceptual and the logical model. We viewed the database in the relational model as a collection of tables. So in the last chapters, we emphasizes on the high level models of a database, that is the conceptual or the logical levels. We viewed the database in the relational model as a collection of tables. So we view the databases in the relational model as a collection of the table that is available in the database. Indeed, the logical model of the database is the correct level of what the database uses to focus on. So indeed, the logical method that is used, the logical model that is used, that is the correct level of database or for database users to focus on. That's why, because this is because the goal of a database system is to simplify and facilitate access to the data. That is how to access or how to store and how to facilitate or how to provide the facility or how to simplify and facilitates how to access the data. Users of the system should not be burdened unnecessarily with the physical details of the implementation of the system. In this chapter, that is in chapter number 11, 12, 13, we probably below the high levels as we describe various methods for implementing the data models. Now, this is the chapter number 10 that is starting up, and in the 11, 12, 13 that is related to the high level methods of implementing the data. Now, first is overview of physical storage medium. That is what is the storage medium or what is the physical storage medium that is used with the database. So then what is the overview of physical storage medium? That is how to use the storage medium or what is the meaning of physical storage medium. So as the name advises, storage medium, that is a physical storage media in which we can store the data, that is a physical. That means we can touch the data, we can store the data, that is a physical storage medium. So several types of data that exist on the data or several types of data that exist that is available in the most computer systems. These storage media are classified by the speed with which the data can be accessed. So there are different types of data. There are different types of data storage that is available with the database, that is available with the data storage that exist in most computer systems. So these storage media are classified by the speed with which the data can be accessed. So how to classify? That is classified by the speed with which the data can be accessed, and also by the cost per unit of the data to by the medium and by the medium's reliability. This is classified by the speed, by the cost, by the medium, reliability. That is how we can rely on the data. Among the media typically available are these. So what are the various physical storage media that is available? One of the media that is available is the cache media or the cache memory. So we can also pronounce as the cache memory, we can also pronounce as the cache memory. There is no hard and fast rule how to pronounce it, but we can pronounce it as a cache memory or as a cache memory. So first point is cache. The cache is the fastest and most commonly or most costly form of storage that is available. Cache memory is relatively small. So this is relatively the small memory. Its use is managed by the computer system hardware. So cache memory is nothing but a smallest or the fastest and the most costly form of storage. Cache memory is a relatively small memory. Its use is managed by the computer system hardware. And we shall not be concerned about managing cache storage in the database system. It is however worth noting that database implementers to pay attention to cache effects when designing query processing data structures in the algorithm. So database implementers or database administrator have to pay the attention to the cache effects while designing the query processing data structures in the algorithm. That is how to process the data, how to query the data, that is the data structures in the algorithm. Then the next physical storage media that is available is the main memory. The storage media that is used for data that is available to be operated in the main memory. This is the main memory that is available, that is a physical storage media. The general purpose machine instruction that operates on the main memory. Although main memory may contain several gigabits of data on a personal computer or even hundreds of gigabits on a different server on a large server computer. So one is a cache memory, one is the main memory. Then there is a flash memory that differs from the main memory in that storage data are retained even if the power is turned off. So if the power is turned off, then also the data will be retained, that is a flash memory. So there are two types of flash memory known as the NAND and the NOR flash. So there are two types of memory that is available, that is the NAND and the NOR memory. Of these, NAND flash has a much higher storage capacity for a given cost. So there is a Capacity that is available of the flash memory that is also available of the flash, that is a NAND and the NOR flash. In the NAND memory, NAND flash memory has a much higher capability, much higher storage capability for a given cost, and it is widely used for data storage in the devices such as cameras, music player and the cell phones, and increasingly in the laptop computers. Flash memory has a low cost per byte than main memory. So this has a low cost byte memory than the main memory. In addition to being non-volatile, that is, it retains the storage data even when the power is switched off. So it retains the data, it is volatile in nature, that is the flash memory. So if the light has gone, if the power has gone, then also the data will be stored. Flash memory is also widely used for storing the data in the USB keys, which can be plugged into the USB slot. So there is a slot that is available, that is a universal serial bus. When we attach the mouse, that is also a USB port. Such USB keys have much popular means of transporting the data, that is how to transport the data between the computer systems. Flash memory is also increasingly used as a replacement for magnetic disk for storing the data, for storing the moderate amount of data. Such disk drive replacement, also known as the solid state or solid state drive. So such storage devices are known as the solid state device or the drives. As of 2009, a 64 GB solid state hard disk drive less than the $200 and the capacities ranges up to 160 GB are used. Further, flash memory is increasingly being used in server systems to improve the performances by caching the frequently used data, since it provides faster access than the disk. So it provides the faster access than the disk that is available with larger capacity than the main memory. That is for a given cost, that is it is available in the main memory. Now this is a flash memory. So one is a cache memory, one is a main memory, one is a flash memory. Then next is the magnetic disk storage, that is how to store the data in a magnetic disk. The primary medium for the large or the long-term online storage of data is the magnetic disk. So primary medium that is available for the long-term data storage or online data storage of data is the magnetic disk. That is the primary medium. Usually the entire database is termed or is stored on the magnetic disk. So in general, entire database that is stored, that is available on the magnetic disk. The system must move the data from the disk to the main memory so that they can be accessed, so that they can be available for the processing. So first of all, it can be stored on the magnetic disk, then it will be available, or it will be going on to the main memory by which they are executed, or from which they are we can say they can be accessed. After the system has performed the designated operations, the data that have been modified must be returned to the disk. So after the system has performed various operations, various we can say the rules, the data can be accessed or the data can be available or the data have been modified, must be written into the disk. As of 2009, the size of the magnetic disk ranges from the 80 GB to the 1.9 TB. Now next is the optical disk. That is the most popular form of optical disk are compact disk, that is a CD, which can hold about 700 MB of data and have a playtime of about 80 minutes. And the DVD, that is a digital video disk, which can hold 4.7 or 8.5 GB of data per side of the disk. The expression digital versatile disk is also used in place of the digital video disk. So either we can apply digital versatile disk, either we can use digital video disk. And the optical disk used in the only read-only form, that is a CD-ROM, that is a compact disk read-only memory, and the DVD-ROM, that is a digital video disk read-only memory. Optical disk jute or the jukebox system contains a few drives and numerous disks that can be loaded into one of the drives automatically on the demand. That is the optical disk property or the optical disk storage. Then next is the tape storage, that is used primarily for the backup and the archival data. So tape storage is used for the backup and the archival data, that is how to take the backup and how to retrieve the data. Although magnetic tapes is cheaper than the disk, access to data is much slower. So although the capacity, or the we can say the price of the magnetic tape is much cheaper than the disk that is available, but accessing the data, or accessing the data is much slower than the magnetic disk. Tapes have a high capacity, that is a capacity of around 40 to 300 gigabyte tapes, and can be removed from the tape drive, so that they are well suited to cheap archival, or to the cheap archival data. The various storage media can be organized in a hierarchy according to their speed and their cost. So the various storage media that is available, that can be organized in a hierarchy. The highest level, or the higher level, are expensive and but are fast. So whatever the highest level that is available, that are the expensive memory, and but they are fast memory. The faster storage media, for example, cache and the main memory, are referred as the primary storage. So whenever we combine, or whenever we known as the cache memory and the primary memory, that is known as the primary storage, or that is referred as the primary storage. Next line says the media in the next level in the hierarchy, for example, magnetic disk, are referred as a secondary memory or the online storage. So the next memory, that is a memory, the next level in the hierarchy, in the that is the next level that is available, that is a secondary memory, secondary storage, or the online storage. So the media in the lowest level in the hierarchy, for example, magnetic tape and the optical disc jukebox, are referred as the tertiary storage or the offline storage. So there is a tertiary storage that is available, or the offline storage that is available. In addition to the speed and the cost of the various storage system that is available, there is also the issue of the storage volatility, or the volatility. So there is also issue that is available with the storage volatility. The volatile storage loses its content when the power of the devices, or to the device, is removed. So whenever the power is removed, then the storage or the data will be lost. That is the volatile storage. And the non-volatile storage means the data will remain up, or will remain constant when the light has, or when the power has gone. And this is the hierarchy of the, we can say, the storage level hierarchy, one of the most important diagram. So first of all, there is a cache memory, then there is a main memory, then there is a flash memory, magnetic tape, optical tape or optical disk, then there is a magnetic tape. So cache memory, main memory, flash memory, magnetic disk, optical disk, and the magnetic tape. So if any data comes, if any we can say the computation or the calculation comes that stores the data, or that have storage, or that have a data that is stored in the main memory, then what happened? The cache requests to the main memory to give the data, to fetch the data, to gain the data, that is a main memory. So there is a cache memory, there is a main memory, there is a flash memory, there is a magnetic disk, there is an optical disk, and there is a magnetic tape. So these are the various levels of the hierarchy that is available. Whereas the storage system that is available are the non-volatile memory. The data must be returned to the non-volatile storage for the safekeeping. So if, for example, pen drive, we can store the data for the safekeeping. Suppose my system has formatted out, so we can retrieve the data from the, we can say the from the pen drive. That is also a backup. That is also a non-volatile storage. Now, next is the magnetic disk and the flash storage. That is in detail we are studying about the magnetic disk. That is what is magnetic disk, and what are the various flash memory or the flash storage that is available in the magnetic disk. So magnetic disk provides the bulk of secondary storage for modern computer systems. So it provides the bulk of secondary storage. Of bulk means the large quantity of secondary storage than the modern computer systems. Although the disk capacities that is available have been growing year after year, that is the capacity of the disk are increasing in the day-to-day scenario, the storage requirement of the large applications have also been growing very fast. So if the storage or the disk capacities are increased, the requirement of the users are also increased, because many of the users are using the internet. So there will be a storage of data that will be available, or that will be done, or that will be carried out by the magnetic disk. Then a very large storage database that may require hundred of disks. In recent years, flash memory storage sizes have grown rapidly, and flash memory is increasingly becomes a competitor the magnetic disk storage for each every applications or several applications. Now, first point is physical characteristics of data. That is, what are the various physical characteristics of the disk, not data, physical characteristics of the disk. That is how the disk will be maintained, or what are the various characteristics of the disk. So, this is the, we can say, the physical storage. This is the diagrammatical representation. That is how to store the data on the magnetic disk. So first of all, let's take a break. Let's take a break for 10 minutes only, then move to the this topic, that is what is the physical storage media, or what is the physical characteristics of the disk, that is how the physically data will be stored on the disk. So let's take a break right now, then move to this topic, that is the physical characteristics of disk. So let's take a break right now. Now come back from the break and let's start the session again. So next is the physical properties or physical characteristics of the disk, or we can say how the disk can be physically stored, or in the which the data can be physically built. So the physically the data are, or the disk are relatively small. That is, disk are relatively small like this one. This is the physical storage of the disk. Each disk platter has a flat circular shape. So every disk platter has a shape, has a flat particular platter shape. This is a platter shape. This is in a round figure that is available. It has two surfaces, or its two surfaces are covered with a magnetic material. So this is a magnetic material that is available, that is covered with a magnetic material. This blue color is a magnetic material. Then platters are made up from the rigid metal of the surface. So every platter has a disk surface. Every platter has a two surface with the magnetic material, and the information is recorded on the surface. And the platters are made from the rigid material of the glass. That is, platters are made for the, or from the rigid material of the glass that is available. This is the platter, that is a rigid material. When the disk is in use, a disk or drive motor spins it at a constant high speed. So the motor rotates in a constant high speed. This is a motor, this is a spindle that rotates in a constant high speed that is available. And there is a read-write arm, there is a read-write head position just above the surface of the platter. The disk surface is logically divided into tracks. So the disk surface that is available is divided into tracks that is available online. So the disk surface is divided into different tracks. These are the various tracks, and there are the various sectors. So these lines are, or these boundaries are known as the tracks. These circular boundary, oval boundaries are known as the track, and in between the tracks there is a sector. This is a one sector. This is one sector. One sector. One sector. So particular squares are known as the sectors, and the boundaries, and that provides the protection, are known as the sectors. And this is a cylinder that is available. This is a cylinder, and this is the read write head. That is the, this is the arm assembly. For example, I am using the arm assembly. Wherever my data is available, that is a read write head that is available. So this is the arm. Then cylinder C, sectors S, that is a platter. There is a track T, there is a spindle motor that rotates. Spindle motor means that rotate with each other, or that rotates in a direction that is available with the spindle motor. So there is a track, there is a spindle, there is a sector, there is a cylinder, there is a platter, there is a rotation that is available with the flat base or with the flat surface, and there is an arm assembly that manages, or that manages the read write arm that is available with the data surface. So this is a magnetic disk, that is the magnetic disk that is available with the data storage, or that can be used for the data storage. And this is the physical storage of the media. The inner tracks are of a smaller size than in the current generation disk. The outer track contains more sectors than the inner tracks. Typically, numbers are around 500 to 1000 sectors per track in the inner tracks. So the typically numbers are the sector that is available with the within the 500 to 1000 sectors per track, and around 1000 to 200 sectors per track in the outer track. The number may vary. Different models, higher capacity models, usually have more sectors per track and more tracks on each platters. That is, there are different models, and the high capacity model that is available, if there is a high capacity model that have a, or that usually have a more sectors per track and more tracks on each sector. There are more sectors on a track, and there are more tracks on the one platter. This is a platter, this is the platter, this is the tracks, and this is the sector. So more sectors, more tracks on the one platter. That is also one of the information if there is a high speed platter that is available. The read write head stores information on a sector magnetically as reversal of the direction of the magnetization of the magnetic material. That is, what is the magnetic material that is available, how it is represented in a magnetic view. That is, a read write head is available. each side of the platter of a disk as a read-write head. So every side is available of platter, that is either the opposite side or the reverse side that is available, that has a read-write head, that is or we can say we can read the data, we can write the data in the on the both sides of the platter, that is available with the different tracks. A disk that is typically contains many platters. So this is a disk that contains many platters. These are the examples of the three platters, but we can store n number of platters within a magnetic disk. And the read-write head is also available of the old tracks are mounted on a single assembly that is known as a disk arm and move together. This is the disk arm. This is a disk arm that moves together to spin the motor, to spin the bundle, to spin the carry out. Each side of the platter of a disk as a read-write ham. The disk platter mounted on a spindle and the heads moves on a disk arms are together known as the head disk assemblies. Since the heads on all the platters moves together when a head on one platter is of the ith track. The heads on the all other platters are also on the ith track of their respective platters. Hence the ith track of all the platters together are known as the ith cylinder. So there is a ith cylinder that is available for the track, that is the tracks of the platter. Today, discs with the platter diameter of 3.5 inches dominate the market. They have a lower cost and fast speed or the fast access time or the fast seek time that is available for the longer distances. Discs with even small diameters are used in the portable devices such as laptop computers and some handle or handheld computers and portable music players. Head crashes can be a problem that is available. If the head contacts the disk surface, the head can scrape the recording medium of the disk, destroying the data that has been there. In older generation disks, the head touching the surface caused the removed material to go on, the removed material to become the airborne and to come between the other heads and their platters. And the current generation disk or the current generation disk drives uses a thin film of magnetic metal as a recording medium. They are much less susceptible to failure by head crashes than the older oxide coated disk. And there is a disk controller that provides an interface between the computer system and the actual hardware of the disk drive. So this is a mediator. A disk controller interface is a mediator that forms as a mediator between the computer system and the actual hardware of the hard drive. The disk controller is implemented within the disk drive unit. A disk controller accepts the high-level commands to read or write a sector, initiates the action such as moving the data, and also provides the checksum. That is, the checksum means till which point we have selected or we have checked our data, that is the data is correct. That is a checkpoint. Another interesting task that the disk controller performs is remapping of the bad sectors. If the controller detects that a sector is damaged when the disk is initially sector formatted, or when an attempt is made to write the sector, it can logically map the sector to a different physical location. So there is a mapping of the storage, there is a mapping of the data that is available on a physical storage. The remapping is noted on the disk and is non-volatile memory, and the write is carried out on a new location. And disks are connected to a computer system through a high-speed connection. There are multiple interfaces that is available like SATA, that is a serial interface or the serial asynchronous transmission data. And there are multiple small computer interconnected, that is a SCSI. Then there is a SAS, that is a serial attached SCSI. Then the fiber channel interface that is provided by the standard, that is the IEEE standard. And then NAS, that is also alternative of the SAS or the SAN. NAS is much like a SAS except that instead of the network storage appearing to be a large disk, it provides a file system interface using network file system protocols such as NFS or CIFS. Next is performance measures of the disk. That is, what are the various performance measures or what are the various measures of the performance on the disk. So the main measures of the qualities of a disk are capacity, access time, data transfer rate, and the reliability. So what are the main measures? That is, the main measures are available or main measures of the qualities of a disk are the capacity, access time, data transfer rate, and the reliability. So these are the various measures. These are the various methods that is used with the. These are the various, we can say, the qualities that is available with the disk. So one is the capacity, one is the access time, one is the data transfer rate, and one is the reliability. Now what is the access time? That is a time that from when a read or write request is issued or to when data transfer begin. That is a access time. That is a time means access time means how to or what is the time required to access the data. That is the access time. So this is the time that is required when a read or write request is issued to when the data transfer begin. So when the data transfer begin, that is the access time. To access the data on a given sector of the disk, the arm first moves the so that it can be positioned or it is positioned over the correct track, and that must wait for the sector to appear under it as the disk rotates. And there are two times that is available. The time for repositioning the arm is known as the seek time, and it increases with the distance that the arm must move. So the time that is available for the repositioning the arm, that is known as the seek time. So the time that is repositioning, that is used for the repositioning, that is known as the seek time, and it increases with the distance that moves with the that moves with the arm, that the arm must move. The average seek time is the average of seek times measured over a sequence of random requests, that is the average seek time. Once the head has reached the desired track, the time spent waiting for the sector to be accessed to appear under the head, that is a rotational latency time. So there is a seek time, there is a latency time. Therefore, the average latency time of the disk is one half the time for a full rotation of the disk. The access time is then the sum of the seek time and the latency time. So the access time means the addition of the seek time and the latency time that ranges from the 8 to the 20 milliseconds. That is the addition of the seek time as well as the latency time. Once the first sector of the data to be accessed has come up into the head and the data transfer begin, the data transfer rate is the rate at which the data can be transferred. The final commonly used measure of a disk is the mean time to failure, that is the MTTF, that is the mean time to failure, which is a measure of the reliability of the disk, that is how it will measure or how it will form the reliability of the disk. So the final commonly used measure of a disk is the mean time to failure. The mean time to failure of a disk is the amount of time that on an average we can expect the system to run continuously without any failure. Disk drive for the desktop machines typically supports a SATA, that is a serial ATA interface, which supports 150 megabytes per second there is a SATA 2, that is a 3 GB interface. Then next is the optimization of the disk block access, that is how to optimize the disk block access. So optimization of the disk block access, that is how to optimize the disk block access that is available. So the request for disk input output are generated both by the file system and by the virtual memory manager that is found in most operating system. So both request that is available for the file system and the virtual memory manager that is found in most operating systems. Each request specifies the address on the disk to be referenced. That address is in the form of a block number. So every address is found in the form of the block number. A block is a logical unit consisting of a fixed unit of a fixed number of contiguous sectors. So a block means a unit that contains a contiguous or the multiple sequence of the sectors. Block sizes ranges from 512 bytes to the several kilobytes. That is, it ranges from the 512 byte to the various kilobyte that is available. And there is a term page that is also refers to the blocks. So there is a page that contains the various blocks. In contrast, in a random access pattern, successive requests for each block are randomly located on the disk. A number of techniques have been developed for improving the speed of access to the block. So there are multiple methods that can be developed for improving the speed of the access to the block. So these are the techniques that is helps in improving the speed, that is how to access the data, how to fetch the data. First one is buffering. That is there is a technique that is a buffering that is done by both the operating system and the database system. Then read ahead, that is when a database is accessed or the disk block is accessed, consecutive block from the same tracks are read in the in-memory buffer if there is no pending request for the blocks. Then there is the scheduling. That is scheduling means at what time the data will be scheduled to store the data. That is the scheduling. There's a discount scheduling algorithm that is increases, and there is an elevator algorithm that is used for the scheduling part. Then there is a file organization, that is how to organize the file, or there is a concept of organizing the file that is available in the sequence access, indexal or the index sequence access, that is any form we can change, any form we can use for changing the files, or we can say for organizing the files, that is a file organization. So to reduce the block access time, we can organize the blocks on a disk in a way that corresponds closely to the way we can expect the data to be accessed. For example, if we expect a file to be accessed sequentially, then the data will be transferred, or the data will be idly keep all the blocks of that file sequentially on the adjacent cylinder. That is how to organize the data, how to we can say use the data that is available with the organization. Subsequent operating systems such as Unix and the Microsoft Windows hide the disk organization from the users and manage the allocation internally that is used. Then next is the non-volatile write buffers. This says since the contents of the main memory are lost in a power failure, so there is a non-volatile concept, there is a NVRAM, that is a non-volatile random access memory that is used for the data storage. We can use a non-volatile random access memory to speed up the data writes drastically, that is used. And there is a log disk, that is another approach to reduce the log disk, that is a sequential access that is available with the data, that is available with the data access. File system that supports the log disk that is available, that is used in the data storage, that is used in the data access. Most modern file system implement generalizing and use a log disk when writing internal file system that is used with the file structures. Now next is the flash storage, that is how to store the flash, or how to deal with the flash that is available with the flash memories, that is a flash storage. So as mentioned in section 10.1, there are two types of flash memories, that is a NOR flash and the NAND flash, and the NAND flash is most commonly used memory, flash memory that is available. So NOR flash allows random access to individual words of memory and has read time that is available to read out the data to that is compared to the main memory. So that has a more random access memory, that has a more memory that is available with the NOR flash memory. However, unlike NOR flash, reading from NAND flash requires an entire page of data, typically consisting of between 512 and 4096 bytes, that is to be fetched from the NAND flash into the main memory. So there is a NAND flash that is available to store the data that is used with the data. But the NAND flash is sequentially or significantly cheaper than the NOR flash. So that is very cheaper in a cheaper rate and more higher capacity and widely used. Storage capacities that is used with the high storage, or with the we can say the storage capacity in the NAND flash is more higher than the NOR flash. And there is a table, that is translation table, that is available. Now next is the RAID, that is a redundant array of independent disk. This is the full form, that is a redundant array of independent disk that is used, that is also a storage medium, that is another physical storage medium that is available. So the data storage, or the data storage requirement of some applications, in particular the web, in particular the database, have been growing so fast such that a large number of disks are needed to store the data. So there's a requirement of the large number of disks, even through the disk drive capacities have been growing very fast. Having a large number of disks in a file system we may present, so there is a concept we can use, there is an organization we can use, that is known as a redundant array of independent disks, that is a RAID, that have been proposed to achieve the improved performance and the reliability. That means RAID gives the high performance and the high reliability. The performance is very high, the reliability is very high. In the past, system designers viewed the storage systems composed of several cheap, small, as a cost-effective alternative to using large expensive disk. The cost per megabyte of smaller disk was less than that the larger disk. Then how or what is the improvement of reliability via redundancy? Let us first consider the reliability. That is one of the solution to of the problem of the reliability is the introduce the redundancy. That is removing the redundancy or initiating the redundancy. And then how to or what is the improvement in the performance via parallelism? That is what is the main difference or what is the main requirement of the improvement, what is the main requirement of the parallelism. So let us consider the concept of the parallel access to the multiple access. With data mirroring, the rate at which the data readout data by which we can read the data that is available with the data storage. With the multiple disk, we can transfer the data, we can move the data, we can use the data that is available on the data storage. That is known as the data storage. That is used for the bit level stripping that is available. There is also a byte block level stripping that strips the block across the multiple disks. It treats the array of disk as a single large disk with the block number that start with the 0. So this is the RAID 0, this is the redundant stripping, this is the RAID 1 that is a mirrored block, this is the RAID 2 that is a memory style error correcting codes. Then there is a RAID 3 that is a bit interleaved parity that is available. Then there is a RAID 4, 5. These are the various RAIDs level that is available with the RAID concepts. So this is the RAID levels. There are multiple RAID levels that is at the level 0 that is a RAID level 0 that is contains a disk array with the stripping at the level of the blocks. There is a RAID 1 that contains the RAID 0 and the 1. RAID 2 that is known as the memory style error correcting code or that contains the ECC that is the error correcting code that is correcting the errors. Then RAID 3 that is also available, that is single parity bit that is used. Then RAID 4 that includes the block interleaved parity organization. Then RAID 5 that includes the block interleaved distribution or distributed parity that improves the level 5 or level 4 by partitioning the data and the parity among the n+1 disk. Then RAID 6 that includes the P plus Q redundancy scheme that is much like the RAID level 5 but store extra redundant information to guard against multiple disk failures. Now what are the various choices of the RAID level, that is how to choose the disk or the RAID level, that is what are the various performances that is used with the RAID levels. So what are the various we can say the choices, that is how to choose the level. First of all, monitoring cost of extra disk storage requirement. So there is a requirement of the extra disk that is available, that is a requirement of the RAID levels. The next is performance requirements in terms of the number of input output operations. So there is a performance requirement that is available that is used in terms of the input output operations. Then next is the performance when a disk has failed. Then performance during rebuild. So the time to rebuild the data of a failed disk can be significant and it varies with the RAID level that is used. There's a choice, and there's a choice between the RAID 1 and the RAID 5 is very harder to make, because that is RAID 1 is also used for the application of the log files, and the RAID file has a lower capacity overhead than the RAID 1. Then next is the what are the various RAID hardware issues that is available in the RAID. So there are multiple hardware as well as the software issues that is available with the RAID, like latent failure, bit rate, and to minimize the chance of data loss, RAID performs a scrubbing, that is during the period when the disk are idle, that is used. Now, what are the various RAID applications? So these are the RAID applications that includes the array of disk, broadcast, and data. The most important concern is that what is a RAID? That is a redundant array of independent disk. That also a disk that is used for storing the data. There are multiple levels of data, RAID, that is RAID 0, 1, 2, 3, 4, 5, 6, and what are the various observations that is used with the RAID levels. Next is the tertiary storage that contains the optical disk, magnetic tapes, and then there is a file organization. So this I am going to start in the next class. That is the next topic, that is a tertiary storage. So that's all for today's session. We wind up this class over here only. And in the next class, that is in the tomorrow's class, I am taking to the next topic, that is the tertiary storage. So that's all for today's session. If there is any doubts, then you can ask the doubts. Any confusion, you can ask the confusions. So thanks a lot everyone for listening me. Bye bye everyone. We will meet tomorrow with in the same timing, that is a 4 to 6 according to the IST, with the topic that is the tertiary storage. Thanks a lot. Bye bye.